All right, so I'm back for more calc prep. Yesterday we learned about standard position. We learned about the vertex of an angle. We learned about the initial side, the terminal side of angles, and then we learned about solving cosine sine for basically radiant or angles. Angles. Um, So, just really quickly, standard position. This is referring to an angle whose vertex is at the origin, and initial side is parallel, or no, is all along the x-axis. We also learn about reference angle, which is the acute angle where the terminal side and the angle made by the terminal side and the x-axis. Initial side is that, again, x-axis. Terminal side is the side that's moved, quote unquote. It helps us determine which side, which is like the interior angle, which is the exterior angle. What angle are we paying attention to? Kind of directionality of the angle. They're concepts, but yeah. I'm not gonna spend too much more time on that. So I'm gonna jump back in, continue learning more, and then I'll be back to recall what I learned in a little bit. Let's talk to you in a bit. All right. Knocked out like 4 topics, I should say. First was reference angles. So we already talked about reference angles. This is the acute angle that is created with via the terminal side of the angle and the x-axis. So pretty simple there. Once I know what a reference angle is, it's pretty easy. You either just like, if it's 200, the reference angle is going to be 20. If it's negative 200, the reference angle is going to be 20 again. If the angle is 85, the reference angle is 85. If the reference angle is 120, the reference angle is 30. So you're just going to subtract like the largest multiple of 90 that's less than the angle if it's positive. If it's negative, then you're going to add the largest multiple that's less than, largest multiple 90, less than, or greater than the number, I should say. Okay, reference angle is good. Trig, solving some trig, simplifying trig statements with trig identities. So there's 3 fundamental type of trig identities that we're talking about, 3 fundamental identities. Reciprocal identities. So there's the 6 trig functions, right? Sine, cosine, tangent, cosecant, secant, and cotangent. And so sine equals 1 over cosecant, cosine equals 1 over secant, tangent equals 1 over cotangent, cosecant equals 1 over sine, secant equals 1 over cosine, cotangent equals 1 over tangent. Those are the reciprocal identities. Then there are quotient identities. Tangent equals sine over cosine, cotangent equals cosine over sine. Those are the quotient identities. Then there are the Pythagorean identities. Sine squared plus cosine squared equals 1. Yeah, I'm good with that one. Then the ones that were actually most difficult. Tangent squared plus 1 equals secant squared, I believe. And cotangent squared. That's simple. The co and co go together. Cotangent squared plus 1 equals cosecant squared. I think I may have learned those with the subtracting by 1. That's why they didn't stick right away. Okay, good. Simplifying trig expressions. Reference angles, simplifying trig expansions, solving right triangles. Simple. I don't know how Alex thought I missed that. Maybe I made a mistake or something. Solving right triangles easy. Cotangent, or really use sine. Use the trig functions sine, cosine, and tangent, and opposite, adjacent, hypotenuse, and the triangle adds up to 180 degrees. Right triangles, solving right triangles, I don't know why. That's simple stuff. I don't know why I had to do that. Anyway, those are the only 5 topics I'm allowed to do for trig right now, but there's more topics than that. So maybe I have to complete these to advance the more complicated ones. But anyway, we've laid a foundation for trig topics so far, basically doing one of each. And I'm just not going to touch them again for a while. And then I'm going to come back and do them cold without having like the one problem with Alex is like it's like emphasizing mass practice, but that's not how to do it. So I did learn the topic, do one problem, leave it, come back way later. Like I'm talking after I've done one of every topic that's available. So now we've moved into exponentials and logarithms. I was kind of upset that I couldn't remember how to do logarithms, but it's starting to click back into place again. So I was able to reason through and figure out what a logarithm is today. It must have just came back from memory. Basically, it's log base, the final number equals the exponent. So it's saying you're finding an exponent with logarithm. You're saying you're trying to find the exponent. So say to what power of this base must I be to get this value, and that will equal that exponent. So equaling exponent. I never learned the change of base formula because I had a calculator that could do it, but Alex doesn't provide a calculator that can do bases other than 10 or natural log. So I had to learn change of base formula really quick. Basically, you've got a log base A. I don't know how to read that. B. So base A, but the value is B. Basically, to change the base there, you're going to say that equals the fraction in the numerator. It's a log with, say, base 10 or whatever base. You can use any base, but base 10 for this example. And then A divided by log base, same base as above, 10, and then B. So simple enough. Reference angle is always positive. It's never negative. So yeah, I don't even know why I missed. Now Alex is saying I missed this. They called finding the time to reach a limit in a word problem on exponential growth and decay. But really, it's like compounding interest. That problem was compounding interest. And I know the compound interest formula, and I don't know why I have, but apparently Alex decided no way he knows that. We gotta make sure he knows that. Even though I took a test, there's no way I missed a problem on that. I didn't get quizzed on it, I remember. So that's it for today. That is 4 more topics we've just ripped through. That's it for today. Be back tomorrow. Talk to you then. See ya.